Today we're going to talk about what is vector. So here is a vector, and this is a head, and here is a tail. And vector do not have location, must have magnitude and direction. So here is a vector, here is a vector, but because of vector do not have location, so they are the same. This is his magnitude and his direction. Scalar quantities vs vector quantities. Scalar quantities only have magnitude, such as speed, mass, height, time, and distance. And vector quantities have magnitude and directions, such as velocity, acceleration, displacement, force, and momentum. Okay, vector have a few kinds. First, opposite vector have the same magnitude but opposite directions. So here they have the same magnitude but different directions. And equal or equivalent vector, they have the same magnitude and same direction. These two are equal vectors. And parallel vector, they not necessarily have the same magnitude, and they have same or opposite directions, such as equal vector are parallel vector, or opposite vector are parallel vector, or this one is also parallel vector as long as they are parallel. Okay, now we have a triangle. This is capital A, this angle, and this length, and here is angle B. This length is more letter B or C, and here we have the length is also C. We can use two methods to find the angle or the length. First one is a law of sine. Law of sine is equal to sine over sine A equals to B over sine B equals to C over sine C. We also can write sine A over A equals to sine B over B equals to sine C over C. It's the same. And the other one is law of cosine. Now, let's think about the Pythagoras theorem. Pythagoras theorem is used in the right angle, like this one. Here's 90 degrees. Here is A, here's B, here's C. And A squared equals to B squared plus C squared. Law of cosine is similar as this one. So A squared equals to B squared plus C squared minus 2 times B times C times cosine A. Yeah. So B equals to A squared plus C squared minus 2AC times cosine B. C squared equals to A squared plus B squared minus 2AB times cosine C. Okay, now let's think about the right angle. This one we also can write minus 2BC times cosine A. And here is cosine A. A is equals to 90 degrees. And cosine 90 degrees is equals to 0. So this one, we call it collection factor, is equals to 0. So we can ignore this one, can only write A squared plus B squared equal plus C squared. And Pythagoras theorem is only used for the right angle. These two can use for any triangles. Now let's do some examples. First is that angle B equals to 65 degrees, and angle C equals to 40 degrees, and B equals to 3. And what is the length of C? So first, so think about it, what the law can we use? Yeah, it's law of sine. So we can write 3 over sine 65 degree equals to C over sine 40 degrees. So C is equals to 3 times sine 40 degrees over sine 65 degrees. So C is about 2.13. And be careful here, we round only once time. So don't round the degree in here, round here for the final answer. Okay, then the next one. B equals to 8 and A equals to 8 and c equals to 5. So which law should we use to find the angle C? Yeah, we should use the law of cosine. Here's C, you can write 5 squared equals to 8 squared plus 8 squared minus 2 times 8 times 8 times cosine angle C. So cosine angle C equals to 8 squared plus 8 squared minus 5 squared over 2 times 8 times 8. That angle C equals to cosine inverse 8 squared plus 8 squared minus 5 squared over 2 times 8 times 8. Since we only round the degree only once time, it's about 36.42 degree. Yeah, very good. What is resultant? So here we have a vector A. Here is a vector A. We have a vector B. Here's a vector B, and the resultance is equals to vector A plus vector B. So here to here is a resultant. Here to here. This one is the resultant. Okay. Now I think you guys already learned about what the resultant. Next, let's talk about the addition and subtraction of geometric vectors. So vector addition. We have two methods to solve the vector additions. Number one, head-to-tail method. Number two, tail-to-tail method. So head-to-tail vector, here we have a vector A. Here we have a vector B. And we add them to head-to-tail. This is his head-to-tail. And this is his resultant, equals to A plus B. And the next one is tail-to-tail method. Here is a vector A, and here is a vector B. We add them to use tail-to-tail. This next thing about the parallelogram method. So we put A vector to here, and let's use a parallelogram. This is vector A, a new one, and this is the resultant. So we use triangle law addition to use head-to-tail and use parallelogram method to tail-to-tail. Now, let's think about which one is more useful. This one. The head-to-tail method is more useful. Why? Because we can add more, we can join more vectors in here. Like we can join here, here, or here. But tail-to-tail method, we only can join two vectors. So now here's example. There is a vector A and vector B, and the angle between the vector is 60 degrees. Here is a vector A, and here is a vector B. The angle between the vector is 60 degrees. Please be careful here. The tail to tail is the angle here. Because since this is a triangle, so we use head to tail. So this one is the resultant, equals to vector A plus vector B. And since this is a parallelogram, so here this angle plus this angle is equals to 180 degrees. So this angle equals to 180 degrees minus 60 degrees equals to 120 degrees. So now we use cosine law to try to find the resultant. A plus B squared equals to A squared plus B squared minus 2 times A times B cosine. Remember, use this degree. Is 120. So A plus B is around square root 19 is about 4.36. Now let's talk about the vector subtraction. Subtract means add the opposite vector. So A minus B equals to A plus opposite vector B. So now here example. A vector A magnitude, absolute values, it means the magnitude of A. So this mean the magnitude B. So what is A minus B? A minus B equal A plus opposite vector B. So it's 3 plus negative 2 equals to 1. As I said before, we already talked about the opposite vector, equal vector, and a parallel vector. Now let's talk about the zero vector. So here is a vector A, and here is opposite vector A. So if we join them together, we got the zero vector. So zero vector magnitude is equal to 0, but we have no specific directions. So we can write zero vector as 0, or this one is equals to 0, but be careful, this is not equals to 0.